Hi class, today we're doing section 1.7, the chain rule. And in using the chain rule, we'll be finding derivatives of functions that can be broken down into a composition of two functions. And then we're going to find the derivative using the extended power rule or the chain rule. So let's go ahead and dive right into it. Let's start off with the definition of a composition of functions. We have a composed function f of g, or f composed with g, and that means that f of g of x is the same thing as f of g of x, where g of x replaces the variable in the f of x function. So here I have two functions, f of x is 3x plus 7, and g of x is x squared minus 8, and I'm going to compose them in two different ways so that you can see how it works out. For the first one, we're going to say f of, and inside of that, we'll put the g of x. So that means we'll write the f of x function first, replacing the x with parentheses. So it's 3x plus 7. And then for my parentheses, I'm going to insert what the g of x was. So that's going to be x squared minus 8 inside my parentheses. Let's watch this again with g composed with f. So g of f of x would be g, and inside my g function, I'm going to put the f function. So let's write the g function first, replacing the x with parentheses. So I'll put parentheses squared minus 8. And inside my parentheses, I'm going to put the f of x function. So inside of here, I'm going to put 3x plus 7. And so notice that these are completely different functions. F of g of x will be different from g of f of x, but if you look at it closely, you can see which pieces came from the f function and which inner pieces inside the parentheses came from the g function. And likewise here, you can see which pieces came from the g function on the outside and which inner pieces inside the parentheses came from the f function. Let's do that again with video example 1. We're trying to find f of g of x. So let's rewrite it once. F of g of x. This means f is our outer function, so we're going to write x squared plus 5 first, replacing our x with parentheses. So we're going to write x parentheses squared plus 5. And then inside that parentheses, we'll write 4 plus 3x. Likewise, we have g of f of x, meaning that g of x is our outer function and f of x is our inner function. So let's write the g function first. 4 plus 3x replaced by parentheses. And then inside my parentheses, I'll put the value of f of x, which is x squared plus 5. Even though we could simplify each of these phrases, we don't want to. We want to leave it in this format because it's easy in this format to see which one's the outer function and which one's the inner function. The reason we want to leave it like that is because the chain rule deals specifically with finding the derivatives with composition of functions. So if you have a composition f of g, we know that f is going to be the outer function and g is going to be the inner function. What happens is that you get the derivative of f with g inside of it, and you multiply it by the derivative of g. And the extended power rule is writing the same rule, but instead of doing any composition of functions, the outer function is specifically a power rule function. And so notice that they take that power, they bring it down, and they subtract by 1, and then they take the inner part, and they take the derivative of the inner part. It's a little bit confusing to look at with just function notation and nothing more, so we need to get some practice doing this. Before you can find the derivative using the chain rule, you have to decide what your inner function is and what your outer function is. And this is typically easy to find if you pay attention to where the parentheses are. The entire thing in the parentheses will be our inner function, while the outside of the parentheses, including the exponent outside of it, will be our outer function. And then in order to differentiate this, we would say y prime, and then we take the derivative of the outer function, in other words, the x to the fourth. And so that becomes 4 parentheses to the third power. That's the derivative of this. Inside my parentheses, I still write the same thing. It doesn't change. So this is f prime with the g inside of it. And then I'm going to take the derivative of the inner part, and so the g prime will be 3x squared plus 0. And there you go. Once again, the part in light blue is the derivative of the outer function, filled in with the inner function, multiplied by the derivative of the inner function. One more time. We want to identify in this function which one's the inner and which part's the outer. So the inner function is all the part inside the parentheses, and then the outer function is a part outside of it, including the exponent. So then when we take the derivative, we have to write g prime of x is the derivative of the outside. So you'd say 7 times 3 times something to the second power. Inside that parentheses, we'll put x to the fourth minus 5x squared plus 8. That's the inner function. And then we have to multiply by the derivative of the inner function. Make sure you use parentheses. So we'll get 4x cubed minus 5 times 2x to the power of 1. Let's just simplify just a little bit the portions that we can multiply. So that's really only the coefficient right here, 21. Leave the part in the parentheses. Leave it alone, especially if it's taken to a power. And then let's simplify what we can in the second parentheses. But we don't want to go any further than that. So I want you to simplify the 7 times the 3 and the 5 times the 2, and that's it. And don't multiply out your parentheses. We're done. Recall that when we have a function given to us, this is called y equals. If it says to differentiate, we have to state that this is a new function. So the new function is the y prime. And when we do this function, we should be able to see clearly that there's parentheses to the power of 1/2. So we're going to take that 1/2 down and then put it to the negative 1/2 power. Inside of here, let's put our inner function of 3 plus x to the fourth, and then we're going to multiply this by the derivative of 3 plus x to the fourth. The derivative is 0 plus 4x cubed. And I want you to just write it at least one more time, where if you have a negative power, I want you to put that in the denominator. So we have the 1 over 2. We have this part with a negative power that we'll put down here, plus 3 plus x to the fourth to the 1/2 power. And then this will go into the numerator, 4x cubed. And if we really wanted to do better at this, we would reduce the 4 and the 2. So we could write 2x cubed over 3 plus x to the fourth to the 1/2. But that last step is optional. You don't have to simplify it, unless the question asks you specifically to do that. Because if we leave it like this, then it's obvious to us that we got the 4x to the third as the derivative of the inner function. For part B, before we find the derivative of y, let's just rewrite y one more time. That's going to be 7 times 1 minus x squared to the power of negative 5. Writing it this way with exponents makes it easier to find the derivative. So when I find the derivative, I have to write that it's a new function. I don't put equal signs between y and y prime. And then I'll take the derivative of the outer function. That's 7 times negative 5 of something to the now negative 6th power, because we're subtracting 1. The inner part of this is 1 minus x squared. So far in black we've written the outer function's derivative, and the inner function is in blue. And then we're going to multiply this by the derivative of the inner function. That's going to be minus 2x to the power of 1. Of all of this stuff, everything will be in the numerator except for this one parentheses that's to a negative power. Let's rewrite it. 7 times negative 5 times negative 2x will be positive 70x. And then the denominator will be 1 minus x squared to the power of 6. All right. This next question asks us to differentiate f of x. But f of x has two functions that have compositions of functions, and so we're going to be doing the chain rule and the product rule at the same time. Recall that the product rule is the first times the derivative of the second plus the second times the derivative of the first. So let's get started writing that. Notice I wrote f prime of x to start my derivative. We're going to write the first term. And then now we're going to take the derivative of the second. So we're going to get 7, 5 minus x to the 6th power. And then we have to do the chain rule and then take the derivative of the inside of this parentheses. So that would be 0 minus 1. And then to finish off the product rule, I'm going to say plus the second term, 5 minus x to the 7th, times the derivative of the first. So that would be 3 parentheses squared. Inside my parentheses, we'll leave the 2x minus 7, and then we have to do the chain rule, so the derivative of the inside is going to be 2 minus 0. We're going to take some time to simplify this. First of all, I'm going to pull to the front any coefficients that need to be in the front. Okay, so we get the 7 times the negative 1 becomes negative 7. And then I want to see what parts this has in common with this. And I see 2x minus 7 to the third and to the second. So I'm going to break this up into 2x minus 7 and 2x minus 7 squared. And then 5 minus x to the 6th. And I'm doing this so that this will match the second side. And then I have here a 3 times a 2, so that becomes a 6. 5 minus x to the 7th will become 5 minus x times 5 minus x to the 6th, and then 2x minus 7 squared. You might be wondering, why did I do it this way? Because I want to find the pieces that they have in common. So they have 2x minus 7 squared in common, and they also have 5 minus x to the 6th in common. And so by doing this, we're able to pull apart the parts they have in common. So now I'm factoring out the parts that they have in common, and then inside that, I will just put the parts that are left over. So you can see we factored out the common parentheses portions, and then whatever was left over will get put in here to simplify as much as possible. Take care when you're doing this step that nothing here on this side changes, but the things inside this part change, and that if you have a negative, you have to distribute it. Make sure that all your signs are correct. Now let's combine like terms. And after I've combined like terms, there's nothing more I can do here. And you'll have 2x minus 7 squared times 5 minus x to the 6th power times negative 20x plus 79, and don't try to multiply this out. This is your derivative. Whenever we do the chain rule with the product rule, you will have pieces in here that match because of where they're coming from, and because of the functions and the way that you do the functions times the derivative of the other function. you will have pieces that match, so you need to be able to isolate those pieces that match, factor that out, and then pull in the pieces that didn't match and simplify them, and then get to a step like this. Let's try it one more time. To differentiate f of x, we need to use the quotient rule combined with the chain rule. So we are going to be finding the derivative of this fraction, which will be the bottom part times the derivative of the top minus the top part times the derivative of the bottom, all over the bottom squared. Let's color code it first. So first of all, we have to state that we're getting the derivative, so we're getting f prime. And we're going to write the denominator times the derivative of the numerator. So that derivative would be 4x minus 0. And then we have to put minus. Then we write the numerator, 2x squared minus 1 times the derivative of the denominator, which is going to be 2 times the parentheses to the power of 1. And then now we need to take the derivative of the inside. This is where we're doing the chain rule. And we're going to get 3 times 4x cubed plus 0. You want to put all of this over the denominator squared. Now I'm going to rewrite it, making sure that the parts that are highlighted, which are the same on both sides, are pulled out of all the other terms. And so you have the 3x to the 4th plus 2 left over, and then the 6, and the x squared, and the 2x squared minus 1 left over. And then rewriting it one more time, to factor out the parts they have in common, I leave in brackets the 3x to the 4th plus 2, and then minus the 6, the x squared, and the 2x squared minus 1. And then I want to simplify what's in the brackets. Notice that I have a 3x to the 4th plus 2 here, and I have a lot of them down here, so I'm going to reduce once. And I'm going to get and then I want to simplify this by adding like terms. So here's our derivative, simplified. Let's talk about each step of the way. Once again, just like the product rule, what we did is we found what pieces they have in common so that we could separate those out from the rest of the terms, making sure that we keep the minus between the first terms and the last terms. Once again, isolating out those parts that they have in common, and then collecting in this brackets all the parts that we need to simplify. And then now that I've done that, I did reduce this fraction because this became factored out, so I could reduce it. And then I multiplied the negative 6x squared times everything in this parentheses to give me negative 12x to the 4th plus 6x squared, which allowed me to combine like terms. And so there you go. There's the final answer. That is f prime. In order to do example 5, we should notice that there's multiple sets of parentheses and multiple nested functions. And so basically we're going to be doing the chain rule twice. So first, when it says differentiate, we're given the function f of x. To differentiate, we would write f prime of x. And let's just do the outermost function. That'd be the parentheses to the 8th power. So the derivative of that would be 8 parentheses to the 7th power. inside this parentheses, nothing changes. So we're going to write x cubed plus parentheses 9 plus x to the 5th power. Now what we need to do is the chain rule and take a derivative of everything I just wrote in blue. We'll call that our inner function. So I'm going to multiply by the derivative. The derivative of x cubed is 3x squared plus the derivative of this parentheses is going to be 5 parentheses to the 4th power. The inside of this parentheses is now our second inner function, and so we're going to put 9 plus x, and now we're going to multiply this by the derivative of the inside. So 9 plus x, the derivative becomes 0 plus 1. And there's not much we can do to simplify this. You just want to double check to make sure all your parts are correct. So let's just double check. We have the outermost parentheses, which was to the power of 8. The 8 came down. We took it to a power of 7. We then wrote the inside without changing it at all. Then we took the derivative of the inside over here. So that's 3x squared plus 5 parentheses to the 4th. We take the inside of that parentheses without changing it at all, and then we multiply by the derivative of the parentheses. Now that we verified it, it's all correct, we're done. In video example 6, we're doing a version of the chain rule using two separate functions, writing them separately, and then asking us to find the derivative. Notice that y is in terms of u, and then u is in terms of x, but we're asked to find the derivative of y with respect to x. And so what we want to do is find dy du first, and then find du dx. As alternative to what these steps are doing, what we could do is take this u and substitute it in here, and then find the derivative using the chain rule. But because we're given two separate functions, we have the ability to try this different notation. So when it says find dy du, that means find the derivative of y with respect to u. Dy du is this derivative. That would be 2u plus 1. And then du dx would be the derivative of u with respect to x. So that would be 2x plus 1. Now to find dy dx, what we're going to do is find dy du, and then du dx, and so that becomes dy dx. So that's 2u plus 1 times 2x plus 1. But we want all of our terms to be in terms of x, so this u is out of place. So we're going to replace the u with what it's equal to, x squared plus x. So I'd write 2 parentheses x squared plus x plus 1, parentheses around that whole statement, and then 2x plus 1. In this example, our y equals to u squared plus u is our outer function, and then this is the derivative of the outer function, and inside this derivative of our outer function, we have our inner function, which was u is equal to x squared plus x, and then we are multiplying by the derivative of our inner function. And so this is a version of the chain rule. In video example 6, we're given the y equation with the u as the variable in it, and then we're asked to find dy du. Then we have the u equation with the x variable in it, and that gives us du dx. And then we'll combine that to find dy dx. So we're going to do the chain rule. And before we do it, I want to rewrite y as 2 plus u to the 1/2 power. That'll help us so that as we find dy with respect to u, then it's easier to look at. So the derivative of this is 0 plus 1/2 u to the negative 1/2. In other words, that is 1 over 2 u to the 1/2 or 1 over 2 radical u. Then we have u is equal to x cubed plus 1. To find du dx, then we're going to take the derivative with respect to x. We get 3x squared and plus 0. So then we won't write that part. To get dy dx, what we're going to do is get dy du and then du dx. Let's rewrite this. You get 1 over 2 radical u times 3x squared. Except for this doesn't match. We have u and we have x. So we want to replace that u with what it's equal to. X cubed plus 1. So we get 1 over, so we get 3x squared, that's the 1 times 3x squared, all over 2 radical, and then instead of u, we're going to write x cubed plus 1. Let's look at the notation. We had an equation, and we rewrote the equation using y equals. Then we found the derivative using dy du, and there's our derivative. We wrote the equation, we found its derivative using du dx, and then to find dy dx, we took the dy du, multiplied it by du dx to find our dy dx. We made sure all of the variables in our final equation were in x, so we had to substitute out the u that we found. Question number 7 asks us to find dy dt. And here's a hint. Start by finding dy du and du dt. dy du would be based off of this y equation, and so that would be 2u minus 3. du dt would be based off of this equation, and the derivative of that is 5. So dy dt, which will be based off of the derivative of y with respect to u, and then the derivative of u with respect to t, is just going to be 2u minus 3 times 5. And then don't forget that we don't want to have anything in u, we want to have it with respect to t. So I'm going to write 2 parentheses 5t minus 1 minus 3 times 5. And I'm getting that 5t minus 1 to replace u from this equation up here. I can simplify that. That's 10t minus 2 minus 3 times 5. So dy dt is equal to 50t minus 25. There we go. This word problem talks about a video game company, and Game Boss Video releases a special commemorative game. The company's profit in thousands of dollars from sales of this game is given by y is equal to u squared plus u, where u is the number of units sold. If the number of units sold is given by u is equal to x squared plus x, where x is the number of days since the game is released, then it tells us to find dy dx. After we find that derivative, it asks us to evaluate it at 5, at x equals 5, and to explain what that means. From our last 3 questions, we should know how to do dy dx. We're first going to find dy du. So the derivative of the y equation with respect to u is 2u plus 1. Then the derivative du dx is the derivative of the u equation with respect to x, 2x plus 1. Then we know that dy dx will be a result of dy du, and then du dx. And so we're going to write 2u plus 1 times 2x plus 1. And that's not okay because it has both u and x in it. And then we have to replace the u. So we're going to replace it with x squared plus x. Let's simplify it a little bit. Now it tells us that after we find dy dx, it wants us to evaluate it at x equals 5. So let's plug 5 into this equation. So after plugging it in, let's simplify. And after simplifying, we get 671. But what does that number mean? Well, to be able to understand what that means, let's go back to the name of this function. It is dy dx. It is the change in y over the change in x. The change in y, well, y stands for the company's profit in thousands of dollars, and then x is the number of days since the game was released. So 5 days after the game was released, the change in money, the change in sales is $671,000. So you want to make sure you put the dollar sign here because that's what the y variable stands for, and you want to say per day because that's what the x variable stands for. So it changes, the sales changes $671,000 per day, 5 days after the release. All right, that's it for section 1.7, and that's it for this week.